Here is a slightly complex statement to read. O is going to look at it, try to read it, and let me read it too, क्योंकि मुझे भी नहीं पता ये क्या लिखा हुआ है. Yeah, let's read it. So this part is just defining two real numbers, okay? And this part is defining another real number. Okay, so this part is exactly the same जो हमने ऊपर देखा है, okay? जो ऊपर हमने देखे हैं ये वाली statement, it's the same. The second part is interesting.
One of the numbers belong into the same domain. Second part.
One of them is not unique.
Okay. See. Okay. Any more tries? This is a very interesting statement, and it's not that hard.
What does P stand for? What does P stand for?
P is a particular statement. We don't know what P means. Okay. P means, for example, square. Okay. I don't know, but P is a statement जो हमें नहीं पता कि क्या है. Okay. P is a predicate.
One of the number belong to the domain of Z.
Anyone else?
All Z numbers, all real numbers belong to Z. I'm sorry.
There are two distinct numbers for which P is true, and at least one of them, and for at least one of them, all P is true. Every P.
So I'm gonna क्या
तमाम जी के लिए कोई एक तमाम जी के लिए या तो में से एक
This is very simple statement. मैं आपको आंसर बताऊंगा and you will be amazed. This is a very simple statement. So the statement says that P is only true for two real numbers. That's all it's saying. And let me tell you how. Okay?
So, what does the statement say?
The statement says that P is only true for two real numbers, two distinct real numbers. That's all the statement is saying.
On the right-hand side or the entire statement?
The entire statement. The entire statement is saying that P is true for two distinct real numbers. That's it. Only two distinct real numbers. Try to see this before I tell you. So the thing is, let me. So this part, the first part is the same as before. The first part is saying that there are two distinct real numbers for which P of X is true, right? So the first part is saying that there are two distinct real numbers for which this is true. The second part is saying that for every real number, Z, for which P is true, right? It must be either X or it must be Y. It can't be anything else. Okay? So take those two real numbers for which this is true, then it can't be true for anything else. It can't be true for any third real number. Okay? So this is a very sort of a tricky way to write the same statement. The first part is saying that it's true for two real numbers. The second part is saying that it's not true for any other real number. Okay? For any real number, if it's true, that real number must be either X or it must be Y. Is it clear? Make sense?
So the second part.
Yes, sir.
Okay, I'm going to repeat once again. So the first part is saying that it's true for two real numbers. And the second part is saying for all real numbers, if P of Z is true, then that real number must be either X or it must be Y. जो कि हमने यहाँ पे डिफाइन किए हैं. Okay, it can't be anything other than x and y. Okay, ये implication है ना? This implication is, yeah, this is an implication. It says that if p of z is true, then z must be x or it must be y. Okay, it can't be anything else. So imagine करें कि आपके पास अब दो नंबर ले लेते हैं 22 और let's say 29, जिसके लिए स्टेटमेंट ट्रू है. Okay, so let's say x is 22, y is 29, तो फिर ये वाला पार्ट ट्रू हो जाएगा. Okay, and this part is saying imagine any other real number, let's say x. Okay, and p of x is true. Sorry, x is a bad thing to use here. What should I use? Let me use alpha. Okay, so let's say p of alpha is true. So this statement is saying that if p of alpha is true, then alpha must be either 22 or it must be 29. Alpha can't be anything else. Okay, so this whole statement is saying that there are two real numbers for which p of x is true, and this statement is saying this is not true for any other real number. So the whole statement is saying that the p is true for only two distinct real numbers. Amazing, isn't it?
The p could be any function like divisible by 3 or square or anything.
Yeah, p could be anything. P is an any variable function.
Okay.
Okay.
But sir, why do we need this added piece of information when we were already good with the first part?
So the first part says that there are two real numbers for this statement is true. It does not restrict that there are more than two. Okay, so it's possible that there are 100 random real numbers for which p is true. Okay, the second part restricts that it's true for only those two real numbers. It's not true for any third real number. Okay, the first part does not restrict it to just two. It's saying that there are at least two. Okay, it's not saying that there can't be more than two. Okay, so the first part says that there are at least two, and the second part says that there are not more than two. Okay, so the whole thing is saying that there are exactly two.
Yeah, got it.
Awesome. Okay, anyone else? Are we good? Okay,
Yes,
so we had these two parts. The first part says that there exist two distinct values that make the statement true. The second part says that out of all values, the statement is true for only x or y. Okay? We combine, that says there are exactly two values that make the statement be true. Okay, here is a statement. Every adult is married to exactly one adult. How do we write it?
For all m and for all w, p or mw.
So for all x, let's use x. For all x, what?
And for all y.
For all y. Are you sure?
Extension.
Let's say for all y. And what do you want to say? So
function.
Let's define pxy. Okay, p of xy मैं define कर रहा हूँ as x is married to y. Okay. So for all x, for all y, what do you want to say?
There exists a
For
y.
all x, there exists a y for which
p of x, y.
Okay, when I erase this part, for all x, there exists a y.
p of xy.
P of xy. That's it?
Yes, sir.
No, but this thing is saying that everyone is married to someone. Okay, so if I'm everyone to everyone, I would still get this statement to be true, right? It's not restricting exactly one adult. You want to make sure that x can't marry to more than one people, right? Remember, there exists is saying that there is at least one y. It's not restricting कि एक से ज़्यादा नहीं हो सकता है.
सर हम इसके आगे फिर मजीद इसको एक्सटेंड कर सकते हैं कि फिर लाइक एंड देयर मस्ट
And
बी
And what?
For every x, p of x1.
So let me write it down. I think I understand what you guys are saying. Let me just write it down. Okay. So and okay, after doing this, I'm writing an and. Let me parenthesize this part. Okay. Um, and for all z, p of x comma sorry
P of Z
p of x comma z implies that
Z
y
is
is equal to z. Sorry, y is equal to z. All right, good. So for the first part is saying that for everyone there is someone. Okay, for everyone there is someone that they are married to. Okay, and the second part is saying that for all z that x are married to, that person must be y. It can't be anyone other than y. All right. Do we all agree that this statement represents this theory?
yes.
Yes, sir.
Awesome. Okay. So we had the part which says that x an adult. So हमने assume कर लिया कि हमारी जो domain है वो adult की domain है. So you can do that. I think you're fine with that. So for all x, if x an adult, then there must exist someone that they are married to. Okay, that's fine. You can bring y out. So here's the complete statement. That for all x, for there exists a y such that they are married to, and for all people that they are married to, they must be y. Okay, so it's the same statement except that added part. They are making them adults. Okay, they're avoiding child marriages or something. I don't know. All right, great. It's the same statement. Okay. So far, we have seen how to formally and systematically write statements.
sir,
Yeah.
sorry to disturb you. I just have a small confusion that if we have specified that z must be equal to y,
Yes.
but does that specifically mean that that y is only one adult?
So the thing is, this statement, if there is someone else that x is married to, तो फिर ये वाला जो part है ना ये false हो जाएगा. Okay. This implication is saying that if x is married to z, okay, then that person must be y. That's why we used implication. That's the implication part. Okay. Implication.
Okay.
Yeah, implication part is making sure that x can't be married to someone else. Okay. Implication part is saying that if x is married to z, then z must actually be y. Okay. It can't be anyone other than y. Okay. So implication यहाँ पे काफी useful है.
Yes, okay.
All right. So here we were. So we have we know how to formally and systematically write statements, okay, using prepositions and predicates. The next question that we want to answer is how to reason and formally prove some of the statements, okay, from a given set of statements. That's the crux of a mathematical statement. कि मैं आपको कोई statement देता हूँ and from जैसे कि हमने लास्ट टाइम लेक्चर में एग्जांपल्स देखी थी, you use the information built in जो भी आपको given है to come up with the new statement. That's the conclusion. Okay, that's where we want to go. So for example, this is our last example for today, and we'll conclude. The example says that I eat spinach or ice cream. Okay, if I study logic, then I will pass the exam. If I eat ice cream, then I will study logic. If I eat spinach, then I will play golf. I failed the exam. Therefore, I played golf. Okay. So these are arbitrary statements, but the question is, can you come up with this conclusion using this information? Okay. So you have this information over here. Can you use this information in these statements to prove the conclusion, which was that I played golf? Okay. So I'm writing each of these statements as variables. I eat spinach. I'm denoting this as S. I eat ice cream. I is I. Okay. So I is a proposition which says that I eat ice cream. Okay. Similarly, L is a proposition which says that I study logic. E is a proposition that says that I pass the exam. Then I have, if I eat ice cream, then I will study logic. This is a proposition. Okay. So this proposition would say something like this. I implies L. Right? Similarly, if I eat spinach, then I play golf, which would say that S imply G. Okay. And then I failed the exam. So I have to end all of these statements. All of them are true. And failed exam का मतलब ये है कि I have not E. Okay. और क्या होगा यहाँ पे मेरे पास? I have
So एक और implication भी है ना, L implies E.
yes.
If I study
so
logic.
L, yes, L implies E. Okay. And what else is there? So S or I is there. Okay. So this is all the information I have. Okay. And from this information, I need to get to this, which is just G, playing golf. Okay. Can I get from all of this jumble to G? So it's written, I've just written the statement. जो ऊपर वाली हमने लिखी थी उसको हमने आसान करके लिख दिया. What is P? What is not P? I think P को मैं exam के लिए use कर रहा हूँ, है ना? Yeah, P is being used for exam. Okay, if I pass the exam, I'm using P instead of E. Okay, so let's see if I can go from here to G. Okay, let's try it. So I have not P here. Okay, what does this mean?
Failed the exam.
Yeah, I failed the exam, which means that P
Study.
must be false, right? Do we all agree on this part?
Yes.
If P is not false, so I would get a true here. Okay, if I get a true here, I would get a false in the negation, and this whole statement will become false. Okay, so P must be F. Okay, so P is F, and I can get rid of this part. When P is F, what does this become?
True.
This becomes true. Okay, when P is F, this becomes true, and anything and true is. So remember, we talked about this. P and true is what?
P.
P, right? This is a tautology. Okay, so I can get rid of this part. Over here.
Excuse me.
Yeah.
But if P is true, then not P would be false, right? So the whole right side of the arrow would be false.
True. Yes, I agree.
Then,
तो इसीलिए
then
P.
the whole thing would be true, no?
Yeah,
Because-
बिल्कुल, I agree. But we need to get a G here. यहाँ पे हमें G चाहिए. Okay. We want to say that this is same as G. Okay. To get G here, I need to make P false. Okay. If I don't make P false, this whole thing becomes false. Do you see it?
Why do we need a G here?
Because I want to prove that this statement is equivalent to G.
Oh, okay.
Okay.
Right.
All right. So we
This arrow is kind of it's kind of confusing because इससे लग रहा है कि this is a whole conditional statement.
I have double arrow here. Okay. I need to show that these two statements are equivalent. Okay. All right, so when P, this P must be false, okay? So P is false, I can get rid of this, and I must have an F here, okay? यहाँ पे P में है. When does this become, what does this become now?
Becomes true because
L must be false.
So when the conclusion of an implication is false, what should the hypothesis be? Can hypothesis be true?
no, it can't be true.
It
No.
can be true, right? We
Must
saw
be
it.
false.
When the conclusion is false, the hypothesis must be false, which means that L is false. Okay. When L is false, this part becomes true. So we come here, L is false. Okay, which means that I must be false. Okay. So
Yes.
I is false. I come here, and I is false. Something or false. What do we get here? So P or false. What's the answer of this?
P.
P. It's also a tautology. We get a P. Okay. So in this case, I would get an S here. Okay. So S must be true.
False.
S must be true, right? Because if this is false, this must be true, right?
Why? But if this is true, then I would study logic.
वो तो स्क्रीन पे है
Oh.
Oh, okay.
No, it does not say that, right? Yeah. So when S is true, I have a true here. And when hypothesis is true, then what happens?
Yes.
You get a conclusion. You get conclusion. Conclusion is also true. And you get a G. And you're done. Okay? So let's see how it happens step by step. Yeah.
सर ये जो S को आपने ट्रू किया ये एक दफा दोबारा बता दें, ये समझ नहीं आया.
So I'm saying that when you have a statement which is S or false, okay, this is a tautology. Okay, this is another way to write a tautology. जैसे ये tautology था. Okay, when this is a tautology, you get an S here. S or F is always S. Okay.
Okay,
So
sir.
these were two forms of tautologies. एक ये था हमारे पास P and something true, and P or something false. These are two forms of tautologies. Statements which are always true.
false हो सकता है, तो ये कैसे tautology हो गया?
So देखो, okay, once again, pick a statement जिसके बारे में तुम्हें नहीं पता कि वो true है या false है. Okay, if you or it with a true statement, you will get that statement.
Yes, sir.
Okay, so what it's saying is that if this thing is true, then S must be true. Sorry,
Yes, sir.
sorry. मैं यहाँ पे this was false. Okay, when S or F is true, then S must be true.
Yes, sir.
Okay, that was it. Okay, I know that this statement is true. If this statement is false, तो फिर सब कुछ false हो जाएगा ना, क्योंकि यहाँ पे and लगा हुआ है.
Oh.
Right? So this statement
Yes.
is true. If this part is F, then S must be true.
ठीक हो गया sir. Thank you.
Awesome, great. So you see how we go from this scattered pieces of information to a conclusion. Okay, so you go from one implication to another, going through tautologies or and to reach your conclusion. This was one way to do it. So I think there are some. So in the slides we actually do it using the rules of inference. Okay, जो हमने use किए हैं. So we know the conjunction, we know the addition, we know the simplification. Okay, so let me move on. You guys can look through them, but let me just tell you कि ये होता कैसे. Okay, so we start with the statement. So all of this is known. Okay, this जो चीज़ known होती है उसको हम premise कहते हैं. Okay, this was already known. We know that I either eat spinach or I eat ice cream. If I read logic, I must pass the exam. If I eat ice cream, I must study logic. If I eat spinach, I play golf, and I fail the exam. Okay, so these are my premises. The first thing is that we get that that from here, because I fail the exam, I must not have studied logic. Okay, this was the first rule that we applied. So from first जो हमारे पास ये fifth statement है, we go from fifth statement to second statement. I'm running out of time. I'll go through this example again on Thursday. Meanwhile, I'll also share the slides with you so that you guys can go through it on your own as well. Okay?
Thank you, sir.
Thank you, guys. See you on Thursday.